So today we are starting a new chapter. It's chapter 12. The first part of today will be a review. It's solving by factoring. We did this a little bit when we were talking about excluded values. We did it a little bit two chapters ago as well. It's the zero product rule that we learned. Yeah. So you've seen this before. We're going to learn another way to solve similar type equations using square roots as well. So first, you can read along in your notes. The steps for these is to make one side equal to 0. So we can use the zero product rule. Then we're going to factor. Then we're going to set each factor equal to 0 and solve. So you end up with like 2 mini equations, sometimes 3 mini equations. And then you solve those. So this one, the hard part's actually already done. It's already equal to 0 and it's already factored. You can tell it's already factored because of the parentheses and the 2 binomials. So our job is to just make each of those equal to 0. So x minus 7 equals 0, x plus 6 equals 0, and then we solve. How would you solve that first one? Add 7 to both sides. We get x equals 7. The second one? Minus 6 from both sides. You get x equals negative 6. So you can write them separately and circle them both, or you can write them in one x equals and just put both answers. I'm okay with either way. What are your questions? All right, here's the next one. Again, the first 2 steps, in my opinion, the hardest part is already done. It already equals 0. It's already factored, written as multiplication. All we have to do is make each equation equal to 0 and solve. So I will write what on my next line?
Y minus 1 equals 0.
Y minus 1 equals 0.
3y plus 4 equals 0.
3y plus 4 equals 0. All right, that first one we just add 1 to both sides. We get y equals 1. Subtract 4 from both sides and divide by 3. Very good. So our 2 solutions here are positive 1 and negative 4/3. What are your questions? All right, here's example 3. Now, this one is already equal to 0, but it is not already factored. So as you're writing it in your notes, think of how you're going to factor something like this. Do what?
I think I was wrong. Take it x.
Yeah, you can divide both terms by x. This is factor using the GCF. So we have an x in the front, and then in parentheses what you have when you divide each of those terms by x. So we will make x equal to 0. We will make x minus 11 equal to 0.
Oh, that's convenient.
Now, x equals 0, that one's already solved. So you can go ahead and solve the x minus 11 one. And what do we get? X equals 11. And those are my 2 solutions. What are your questions? All right, here's number 4. Now, this one is a little harder because none of those steps are done. It's not equal to 0. It's not factored. I pretty much have to start from the beginning. Yes, sir.
Subtract 40.
Yeah, you want to get everything to one side of the equal sign so that the other one is a 0. So we're going to make the right side equal to 0. We're going to do that by subtracting 40 from both sides. Now this is MA. So what multiplies to negative 40 and adds to multiplies to negative 40, adds to negative 3?
Negative 7.
Hold on, what?
Negative 8 and positive 5.
Negative 8 and positive 5. Now, do I have to do the bottoms up division step on this one? No, the leader is a 1. A lot of you are still forgetting that step. Here, if you forgot, it wouldn't be a big deal. But always double check for it. in front of the a squared is a 1, so we don't need to do that step. What I can do now is set them both equal to 0. So a minus 8 equals 0, a plus 5 equals 0. What does a equal?
8 and negative 5.
8 and negative 5. And you can write it as 1 if you'd like. All right, here's example 5. Yep, you want to get everything to one side. We always want the y squared or the x squared term to be the positive one. It just makes factoring so much easier. So I'm going to move the 12y.
Can you factor out of 4y?
Yeah, I can factor out of 4y. So 4y is up front. When I divide 4y squared by 4y, I just have the y left over. Keep the minus sign. 12y divided by 4y is just 3. Now I can make each of those equal to 0. So 4y equals 0. Okay, I'll explain. I'm gonna go rogue. Hold on. Back it up. Sometimes I don't quite agree with the pre-programmed work. I'm gonna make this guy equal 0. And I'm gonna make this guy equal 0. All right, how do I solve that first one?
Divide by 4.
Divide by 4. So y equals 0. Now, the way they did it, they said 4 equal to 0. That didn't give you a solution. Y equal to 0, that gave you y equals 0. I think it's easier just to divide both sides by 4. So that's why it looked a little different. It's the same answer, though. It's the same result. All right, in the back, y minus 3 equals 0. Add 3. Add 3. Y equals 3. What are your questions?
I'm just curious about how did they get that to 4 equals 0 and y equals 3?
So they use the zero product rule for the 3 terms. They consider the 4 and the y separate terms. So they consider like 4
times y.
Yeah, so they use the zero product rule for the 3 different terms. I put 4y together as one term. Same answer though. All right, other questions? Kind of a fun way to do it. All right. Yeah, I need to subtract 20x. Now, where should I write the 20x? Yeah, we want it to go x squared, x, regular numbers. So I'm going to subtract it, and I'm going to sneak it right up in the middle. That way I can factor using MA. Good. So we need to multiply to what?
100.
100. How'd you get 100?
4 times 24.
4 times 24. Good. And I need to add to what?
20.
Negative 20. Negative 10 should work, right? Okay. Don't forget to divide by the leader. Now, what is 10 over 4?
2/5.
5 other way. Yep, 5 over 2. 5 over 2, and then what?
5 minus 2.
Yeah.
We do what with the 2?
Bring it up.
Move the bottom up. So 2x minus 5. 2x minus 5. And then they both equal what?
0.
This guy equals 0, this guy equals 0. Now, if you solve the same equation twice, what do you think's going to happen? You're going to get the same answer. You can really only have an answer once. So we're just going to solve the first one,
X equals
and that's going to be it for us. All right. What's the final step?
Divide by 2.
Good. So 5/2 is the answer here. Questions?
So you don't have to write that twice.
No, you don't have to write it twice.
If you don't write, like on the single ones, like if we just stopped at like x minus 10, do I have to write plus 10 and minus 10?
You can just write it once. All right. All right, already equal to 0, so that's good.
All you can do is factor out an x.
I can start by factoring out an x. So I'll have an x in x outside of the parentheses. In the parentheses, just take down each exponent by 1. So instead of x to the third, it's x squared. Instead of x, there's not an exponent. That is a difference of 2 perfect squares. Good. So how would I write it?
3x plus 4, 3x minus 4.
3x plus 4, 3x minus 4. So keep the x in the front. 3x minus 4, 3x plus 4. If you flip-flop those, that's fine. But it equals 0.
So x equals 0.
Okay, so yes, the x is going to equal 0. The 3x minus 4 is going to equal 0. The 3x plus 4 is going to equal 0. All right, so 3x minus 4, I need to solve that one. I'm going to start by adding 4 to both sides. Then what? Divide both sides by 3, and I get 4/3.
Negative 4.
And then you're going to end up with negative 4/3. Here's why. It's the same thing, but instead of adding, you subtract. All right, so our 3 solutions here are 0, positive 4/3, and negative 4/3. What are your questions? All right, here's the last factoring example, and then we're going to go to the next page.
Well, we're doing 2 sections today.
Again, you were in the restroom when we discussed this. Maybe don't leave for the intro next time. All right, yes, we still have to do solving using square roots. Yeah, subtract the 2. You got to get it equal to 0 first. 2 doesn't have an x with it, so we're going to put it in the back. All right. I need to do... I can't factor out an x because this guy doesn't have an x. What can I do? MA multiply to negative 30. Add to... negative 1.
Negative 6 and 5.
X minus 6. X plus 5. Am I done?
No.
What do I need to do? Divide by the 15. All right, both of those are going to simplify because 6 and 15 both go into, or 3 goes into both of them. So what is that? 2 over 5. In the back, 5 goes into both of them.
1/3.
So 1 over 3. And then you can kick both of the bottoms up. So 5x minus 2 and 3x plus 1. Any questions? I keep saying this over and over and over. A lot of you are still struggling with bottoms up. So where are the problems on this one? Like once you remember to do it, are you guys okay with it? It's just the remembering how to do it step. Okay. Or remembering to do it. All right. So make them both equal to 0. All right. Add 2 to both sides. So 5x equals 2. Yep, so we get x equals 2/5 up front. What about our back equation?
Negative 1/3.
Good. All right, if you want to write them separately, it'll look like that. If you want to write them together, it will look like this. What are your questions on solving by factoring? This is the half that was a review. The next half will be new. All right, so now we're going to look at solving equations using square roots. The key to this one is when something is squared, and then that's the only variable you see. Okay? So if you have the x squared part but no x, you want to try to use this. Okay? And you'll see when we get to some examples. If there's an x squared but no x. Okay? You want to get the x squared part by itself, and then you want to take the square root of both sides. Here's our first example. I'm actually going to show you this one in 2 different ways. The first way is solving by factoring. You don't need to write this part down. Okay, if I said solve this by factoring, what would you do?
Factor tree.
Minus 121.
You would subtract 121 so that it equals 0. And then you do
Square root.
like the ones we were just doing. It's a dot, so you do x plus 11, x minus 11, set them both equal to 0, and you get x equals negative 11, x equals positive 11. Does everyone agree with this method? Okay, I'm going to show you a way that's about 10 times easier. Are you ready? Okay, so I'm going to get rid of this work up top. Do you see how I do not have an x term? There's only an x squared term.
Yes.
What's the inverse operation of squaring something?
Square root.
Taking the square root. So if I take the square root and the squared are they're gonna undo each other. But if you take the square root of one side, you have to take the square root of the other side. What is the square root of 121? 11.
That's exactly what I did.
That is way easier. The only problem is, what is negative 11 squared?
Positive 11.
121.
It's positive 121. When you're squaring a variable, if you plug in a positive, you get a positive. If you plug in a negative, you still get that positive output. Okay? Because of that, we need to sneak in that little symbol, plus or minus. Anytime you take the square root of both sides, you put a plus or minus. And here's kind of another reason why. If I solved it the other way, I would get both solutions automatically. So we need to still consider both of those solutions, even though we did sort of the more shortcut method. What are your questions?
That was 100 times easier.
Now, if this was on a quiz or test, I don't care how you do it. Just arrive at the correct answer. Don't forget your plus or minus.
If it's an even square root, like it goes into an even.
If it's a perfect square,
It's plus or negative.
even if it's not a perfect square, it's still plus or minus. Anytime you take the square root of both sides of an equation, you put a plus or minus. Now, you can only take the square root of both sides when the squared part is by itself. So we don't want the 3 under the radical. Okay, so first, we're going to divide both sides by 3. So a squared equals 25, which is actually a lot better. Why? Just 25 is a perfect square. So when you take the square root of both sides, you'll get A equals plus or minus 5. Good. Raise your hand if you have questions.
That's much easier.
I needed to get the A. I just needed to isolate the variable. Just like any other solving equations, you got to get the A squared part by itself.
Isn't 3a squared already isolated?
The 3 is not. The 3 is bothering the A. I need the A squared part by itself.
Okay.
All right, here's the next one. So I need to subtract 8 from both sides. What is 32 minus 8?
24.
24. It'd be a lot nicer if it was 16, but it's not. All right, then what?
Square root.
Take the square root of both sides.
32 minus square root 24.
How'd I get that? You got to do a factor tree. So 24 is 4 and 6, 2 and 2, 2 and 3. The 2's come out. The 2 and the 3 are stuck on the inside. You still need the plus or minus, even if it's not a perfect square. Questions? All right, here's number 4.
Divide by 4.
All right, what do I do?
Can't you do an
Divide.
automatic square root?
What?
Can't you automatically do a square root?
I don't know what automatically do a square root means.
Like do the square root of 4x squared and then the 9? Because 4 is a perfect square.
I would not get in the habit of doing that. I would always get the x squared part by itself. So how do I get the x squared part by itself? You divide both sides by 4. So x squared equals 9 over 4. Then what? Take the square root of both sides. Hold on. What's the square root of 9?
3.
What's the square root of 4? 2. So plus or minus 3/2. Questions?
Wouldn't you get the same answer either way if we did what I said?
Yeah, I didn't say it was wrong. I just said I wouldn't get in the habit of doing that. All right, here's the next one. Nope. Okay, the whole left side is being squared. How do I undo squaring something? Take the square root. So what's being squared is isolated. It's more than just a variable, but what you're squaring is already by itself. So it's okay to take the square root at this point, because the whole left side is already being squared. Okay? So that's going to leave us with c minus 3 equals
4.
plus or minus 4. This is where it gets a little tricky. Now you need to add 3. So when you add 3, you have to do it to both scenarios. You have to add it to the positive 4 and to the negative 4. Okay? So this represents 2 separate numbers. So if I'm doing something to these 2 numbers, it's actually like 2 different equations at this point. Did everyone follow what just happened? Okay. So when I add 3 to the first one, I get 7. When I add 3 to the second one, I get -1. Some people will also keep it together. Like you could go right from here to down here. And when you add 3 to both sides, it's +3 plus or minus 4. And then they do, like 3 plus 4. That's 7. 3 minus 4, that's -1. Do you see what I'm saying? Kind of the fancy way to write it. It's fun. I enjoy it. Either way, you get these two answers, okay? Questions?
That was difficult.
Let's continue. Okay. Now what? Yeah, that whole left side is being squared. So at this point, I can take the square root of it. So what am I going to have on the left?
Plus or negative, 3t plus 2.
3t plus 2 equals
Plus or negative 5.
plus or minus 5.
I hate when they put t3.
All right, so now here's where you can break it up into two separate equations. 3t plus 2 equals regular 5. 3t plus 2 equals -5. This will give you two different solutions. So both of these equations, you're going to start by subtracting 2 and then dividing by 3. On the first one, I get +1. On the second one, I get -7/3. Because it's -5 minus 2, that's -7.
I put 6 now.
All right, any questions? All right. Take the square root of both sides. So you're telling me -4 times -4 equals -16?
Or 4 plus minus 4.
Negative or positive? Positive or negative?
Can you square a number and get a negative output?
No.
There's no solution.
Oh, wow.
Gotcha. So yeah, you cannot square a number and get a negative output. Because -4 times -4 is +16. And +4 times +4 is +16. So if you're taking the square root of a negative number, you're going to get no solution. Now, if I have you again as a junior, I'm going to teach you something else. It's going to be great. But right now, but right now you just put no solution.
When I put that
Technically, you should put no real solution, but we're not going to be too picky.
when I put it in, it said error, non-real answers.
Right. All right, next. Now, notice how this is example 7b.
Dang it.
Oh.
I know. Tricky.
We don't have this one for so.
You can make a spot for 7b.
Just make a spot for example 11.
I'm so tired.
All right, how should I start this? Subtract the 7. What is 2 minus 7? -5. Yikes.
Wait, no, it's not.
Yeah, this is the point where I would take the square root of both sides. What's the square root of -5? Yeah, error. No solution.
So if you find any errors, it's automatically no solution.
If you're taking the square root of a negative number and you're in Algebra 1, you are going to put no solution.
Can you learn this trick now?
Or we're not the one in minutes.
you're in Algebra 1 Advanced, you're going to put no solution.
Can we learn this trick now?
The square root of -1 is I, so you rewrite it in terms of imaginary solutions. I.
Wait, what?
See? That's all I'm saying. No more. All right, here's example 8.
Where did I come from?
This.
I'll teach you in 2 years.
Just wait till you'll find it.
You'll find out. The suspense might just make you crazy.
Let's just stand up like that.
Hey, you guys are getting a little chatty. We still have 3 examples, so come back in. All right, what should I do?
Divide by 7.
Divide both sides by 7. What is 252 divided by 7?
36.
36. Perfect. Literally, it's perfect. It's perfect square. Ha. All right.
That was so funny.
What do I do? Square root of both sides. Good.
3x minus 1 equals 6. Plus minus 6.
Plus or minus 6. Good. This is where you can break it into the 2 separate equations. So 3x minus 1 equals positive 6. 3x minus 1 equals negative 6. Then what?
Add 1.
Yep, we're going to add 1 to both sides.
X equals
Then we're going to divide by 3, so we get 7/3. The next one, when you add 1, you get negative 5 divided by 3, so negative 5/3. All right, what are your questions? All right. Yep, we are going to start this one by taking the square root of both sides. All right, now I'm going to skip the tree. You guys should be good enough at trees by now that you don't need my help. But if you do a tree, you end up with plus or minus 4 square root 3. Now, for this, I'm going to show it and then I'm going to explain it. Remember how it's both? So since it's a plus or minus, we're going to write both, all right? And then you're going to add 2, and you're going to add 2. Those are the 2 solutions. Now, I am going to give you a different option, very similar to what I showed you the first time we did one where there was a step after the plus or minus. If you want to add the 2 here, you could write it as 2 plus or minus 4 square root 3. This is how I write it. If I was doing this on my own, I would write it that way. Some students find that way more confusing, so they write it as 2 separate answers. Okay? I'm all right with either one. Do you guys have a question?
So that must be the answer, 2 plus or minus 4 squared?
Yeah, that's both answers written in one
I
expression.
like that.
I do too. I think it's more concise, more condensed. But it's not everyone's cup of tea, so there's both options for you. Questions? All right. Final example of the day.
Yes!
Let's let everyone write it. We just got up there. It's a lot to write. Yes.
Would you divide by 6 first?
Nope.
Divided by 2.
You need
Plus 4.
plus 4. Yes. You need to. It's like any other. Think of this part as like what you're trying to isolate. Okay. So if you were multiplying something by 6 and you're also subtracting something by 4, you'd undo the subtracting first, then you undo the multiplying, then you undo the squaring. Okay?
What?
And that
Wouldn't
makes
it
a perfect
be
square.
parentheses exponents multiplication
You do the order of operations in reverse when you're solving equations.
Oh.
So we always undo adding and subtracting, then we undo multiplying and dividing. Same thing here. You want to undo the undo the subtracting 4 by adding 4. Okay?
So then it would be add, subtract, divide, multiply, and 12 in parentheses.
Parentheses is kind of iffy, but yeah, roughly. All right, then what? Divide both sides by 6. What is 36 divided by 6? 6. All right. Here's where it gets kind of confusing. What am I going to do? Now I can take the square root of both sides. So the square root of 6 is just the square root of 6. Plus or minus. All right, what do I do with the plus or minus thing?
Add, subtract.
Yeah, you're going to write it with one of them positive, one of them negative. Subtracting 9. Now, it's kind of weird with radicals. This is normally how you see it written. The number without the radical goes in the front. The number with the radical goes in the back. So even though the 9 is negative, we even said out loud we're going to subtract 9 from both sides. We write it as a negative 9 plus, and then that square root. If you did it the other way, if you did square root of 6 minus 9, as long as you don't put the minus 9 under the radical, it's fine by me, okay? The alternate method, the fancy way, would be negative 9 plus or minus square root 6 like that. Okay?
Would that be x equals?
Of course. Questions? All right, what did we learn about today? We did 2 almost separate lessons.
Radicals or equations of square root.
Solving by factoring was the first thing. And then solving using square roots. Good. All right, here comes your homework.